if f of x equals x squared minus 3x plus 5, then determine in a, it's f of a minus f of 6 divided by a minus 6. We substitute in the expression for f of x. So it's going to be a squared minus 3a plus 5. And then f of 6 is going to be 6 squared minus 3 times 6 plus 5. We drop the brackets and evaluate this bracket here. So it's going to be a squared minus 3a plus 5. And then 6 squared minus 3 times 6 plus 5 is negative 23, or minus 23, divided by a minus x. And we can combine like terms here. 5 minus 23 is negative 18. And the following trinomial in the numerator can be factored into a minus 6 times a plus 3. The two binomials, a minus 6 in the numerator, a minus 6 in the denominator, just cancels. And we're left with a plus 3. Now, we started off with this rational expression here, where we have the variable a in the denominator. So that means that there will be a non-permissible value and there will be restrictions on this expression. Specifically, a cannot equal to 6 because that would result in a 0 in the denominator, which is not permitted. In b, we have f of 2 plus h minus f of 2 divided by h. We substitute in the expression for f of x. So it's going to be 2 plus h squared minus 3 times 2 plus h plus 5 minus f of 2 is going to be 2 squared minus 3 times 2 plus 5. We'll expand the left bracket and we evaluate the right bracket. So we're expanding this 2 plus h squared first. So it's going to be 4 plus 4h plus h squared. Multiply the negative 3 into the bracket using distributive property. It's going to be negative 6 minus 3h plus 5. I'm going to see if I can move this out of the way. Like that. And then for the second bracket, 2 squared minus 3 times 2 plus 5, that equals to 3, divided by h. We can now combine like terms. We have one h squared term in the numerator. And then we have 4h minus 3h, that's just h. And then we have 4 minus 6 is negative 2, plus 5 is 3, minus 3, so that's 0, that actually disappears then completely. And then in the denominator we have h. Okay, now in the numerator we're able to factor out an h, a greatest common factor h, which leaves us with h times h plus 1. And then the 2 h's in the numerator and denominator cancel, and we're left with h plus 1. And of course, again, we're dealing with a rational expression where we cannot have a 0 in the denominator. We have a h in the denominator, which means that our restriction here is going to be that h cannot equal to 0.